Hello everyone, today I'm taking a look at SR-IOV, Single-Root IO Virtualization. So, what is SR-IOV? Well, if you've watched my channel before, I made a video about it in the past about networking. So in the context of networking, I could take one high-end 25 gig network card, split it up into 127 virtual network cards, and pass those individual little virtual network cards directly to specific virtual machines on my hypervisor. In theory, that means I can have a whole bunch of virtual machines that all have access to real physical hardware without mediation or emulated devices in QEMU. But of course, in the world of SR-IOV, there's more than just networking. So today I'm taking a look at SR-IOV with graphics. Now this is much more exciting than networking because there are tons of applications where adding even the most basic hardware graphics capability to a virtual machine can really improve the performance, especially if you're doing anything involving transcoding or Windows desktops. Linux desktops don't need as much, but Windows desktops are really reliant on the GPU. Now, unfortunately for us today, the current market leader in graphics cards, NVIDIA, are on their proprietary bullshit train, so we're not working with NVIDIA today. We're actually going to be working with Intel integrated graphics. Wild, isn't it? But the Intel integrated graphics on this 13th gen Core i5 that I have here are perfectly capable of up to 7 virtual functions. And if you want to run like just 1 or 2 Windows desktops, plus like a jellyfin VM for transcoding or something like that, the iGPU might be all the power you need. So today I have a couple goals for this video. I want to understand first, how do I install SR-IOV for my 13th gen Core i5 on Proxmox? Now, it's not part of mainline Linux, but it is developed by Intel, so we just have a out-of-tree module we have to install and a little bit of work for that, but we'll get over that. Second, I want to pass these virtual functions through into Linux virtual machines. Linux is much easier to work with than Windows, so I'm going to start there and see if I can do some transcoding benchmarks and get a feel for how I can pass this to multiple VMs and how the performance of the VMs impact each other. And if that all goes well, then I'll try to pass this through to a Windows VM and see how it impacts Windows desktop performance. So if all of this sounds good to you, then come along on this adventure. And before I get too far along on this video is brought to you by Moken and their 65-watt smart retractable wall charger. So this thing's kind of like any other cube-shaped charger, 65 watts thanks to gallium nitride power electronics. It's got a US-style plug in the back that easily folds out. But its real magic trick is the built-in cable here. So this thing retracts right out of the body, just like that. So it's 70 centimeters long, so it's about that big in diagonal space. I don't know if you get a feel for that. So it's pretty usable. And that means for a workstation like this, where I'm working all the time, I have projects I'm doing, I'm taking cards in and out for videos. I got my laptop here and I gotta charge it sometimes. So I can pop this charger out and just leave it here on my bench, waiting for me. And then as soon as I need to plug in my laptop, I can pull out the cord, plug it in, and boom, it's ready to go, ready for me. I'm all done for the day, no cable clutter, no excess. I can just unplug this, track it back up there, and it's hiding for tomorrow. So in addition to the retractable cable, there's also a second port on the bottom here. Now these guys can do 65 watts each, and they can do 65 watts combined, and they support power delivery with separate voltages on each port. So if a retractable cable like this would help you organize your bench or working space, get one for yourself at the link in the description below. Now on to the video. So first, install. Now all of this software was developed by Intel ultimately, but Intel hasn't merged it upstream into mainline Linux kernel yet. So it's on Intel's like staging kernel. So a great group of volunteers has packaged Intel's changes into a DKMS, or a dynamic kernel module support module. This means that they're packaging Intel's code as patches, which can get compiled on your system with the kernel you're running. Now we need the SR-IOV supporting driver both on Proxmox, the host hypervisor, and also on any Linux guests. For Windows guests, it may or may not need some work tweaking. So they have instructions on here on how to download the EFI firmware image for Intel iGPUs and pass that through to Windows guests so they can use a standard driver. I did not have to do that, I found. It just worked for me with the standard Intel driver on Windows, but your mileage may vary. But the basic steps for installation is we download the deb package from GitHub. We then install Build Essential and DKMS. We install the deb package, it compiles itself on the system, and it's happy. Their instructions I found were very clear on this. Now the one note I will say is that Proxmox has two different places where the kernel command line could be, depending on if you're using grub or system deboot. The instructions on GitHub are for if you're using grub boot, which some people might be. My systems are running system deboot though, so I use the etc kernel command line file, and I'll put that in the description below as well. So when that's all done, we will get 7 virtual functions from this GPU. They'll show up as 7 new PCIe devices. We can't touch the original physical function because passing that through to a VM crashes everything. So keep the original card 0 render D128 on your Proxmox host. You get 7 virtual functions you can pass through to VMs. I created a Proxmox resource mapping for all 7 of those, so I can just use the iGPU resource and it'll get passed on through to the VM. So with that all set up, I have a Debian Linux guest. It's running Debian 13 Trixie, which is not released yet, but that's fine. I wanted something fairly recent. So let's see how it works. So over here on the server, if I run lspci on PCI root 0002, I get these 8 devices. So these are all this is my physical function, and then the 7 virtual functions. So .0 and then .1 through .7. So just looking at it a bit more, the root device here, 0200, has the capability of Single-Root IO Virtualization, SR-IOV, and it's using the i915 driver. But then all of the sub-devices are, well, sub-devices, so they don't have a whole lot going on. They're using the VFIO PCI driver because they are not used on this system. So then over on my Linux test system, if I run dmesg grep i915, we can see we pulled up the i915 module, and we have DRI card 0 and render D128, as we'd expect. So to the virtual machine, it looks like I just have an Intel iGPU, and I can just use it with any software that's designed to use render D128, which is pretty much everything. So just as an example workload, I'm going to do a transcode with FFmpeg. So I'm telling it to use hardware acceleration on dev DRI render D128. I'm taking bigbuckbunny.mp4 and transcoding it down to H.264 at a lower bit rate. So it's a very low bit rate, so it'll probably look awful, but whatever. So there we go. 107 FPS, that's fine. And back here on the server, I can run Intel GPU top and see what's going on, and we can see the video encoders doing work. It's working. So, well, that's, I guess, all you could expect, right? So now I can pass through one of these 7 virtual functions to a virtual machine, use it for Jellyfin, use it for something like Frigate, Docker containers, things like that, without having to deal with LXC. Not that I don't like LXC, I love LXC. But if you have to use a virtual machine for some other reason, this makes it really easy to pass through your iGPU. So, Windows. It's just easier for me to test Windows from up here. So, using the basic VGA display driver on Proxmox, I installed Windows from the ISO Windows 11, and I went through all the rigmarole to get a local account just for you guys on 3 different VMs. So I got 8 gigs of RAM, 8 CPU cores, the basics. We're on an NVMe mirror, so pretty fast storage. Got that booted up. Then, once I had remote desktop access, I deleted the basic display driver and passed through one of my SR-IOV iGPUs to the Windows guest. And at first it didn't come up properly, but after I installed the latest Intel display driver for Intel, it just worked fine. I got graphics in remote desktop. So this is Heaven. I didn't actually run a Heaven benchmark, I just thought it looked nice in the background. But what I did run is TimeSpy. Not TimeSpy Extreme, just regular TimeSpy. Regular TimeSpy runs at 1440p, TimeSpy Extreme runs at 4K. This is an iGPU, and it basically ran like a slideshow. So at like 5 frames per second on an iGPU, I guess that's kind of what you expect from TimeSpy. But anyway, I got a TimeSpy score of 832. Let's see where that ranks against some other systems. So TimeSpy might have been a little bit optimistic. So next I tried another benchmark from 3D Mark. This one is Night Raid, which is designed for integrated graphics. Perfect for an Intel UHD 770 iGPU. And with Night Raid, I got a score of 10,325, which is much better. So this performance is entirely in line with what I would expect from a UHD 770 iGPU in the virtual machine. So I'm not really losing performance, it's just not a great GPU to begin with. So wanting some comparison, I decided to add a Radeon Pro WX 3100. This is a discrete GPU, but it's not a very good discrete GPU. I chose it because I had it on hand. I felt like my spare RX 580 would be an unfair comparison to the integrated graphics. And these WX 5100s, I think, are the kind of thing you're going to compare to an iGPU. It's like the GPU you use when you just need more display outputs, or you just want basic 3D acceleration for like Windows desktop. So anyway, with the WX 3100, I got a Night Raid score of 15,641. So my UHD 770 is not as good as a really low-end AMD Lexa discrete GPU. But I don't think anyone expected that. But the point is that everything's working, and it's working fine. So now that my SR-IOV virtual functions are passed through to Windows, they just work. And I get graphics acceleration in remote desktop. I will say I did all of my testing through remote desktop to make it fair to the iGPU, which doesn't have any display outputs. So even with the WX 3100 and with no GPU, I was running over remote desktop. Now with no GPU, I couldn't run any of the 3D Mark tests because I don't have 3D, but I could run a different test, that's PC Mark. Now PC Mark also crashed with no GPU, but I was able to get some subsection scores from some of the sections. So because PC Mark had a lot more variation than 3D Mark, I ran all these tests 3 times and averaged the results, and I normalized all the results to the no GPU number. And so my uplift for productivity tasks are somewhere between 5 and 15%, video conferencing was up 20%, application startup was down 10%, not entirely sure why that was, but whatever. If you do photo editing or video editing, you can see like a 60% uplift, which totally makes sense. Having a GPU helps a lot there. Rendering actually crashed without an iGPU, so you can't do that without GPU pass-through. But clearly this made some difference to my virtual Windows session to have even a basic iGPU available for PC Mark. So now that Windows works, and now that Linux works, what happens if both of my virtual machines try to use iGPU resources at the same time? And the answer to this is it depends. And it also kind of shows why this is still in beta and not merged into mainline and not quite ready yet. That doesn't stop me from running it, but you might want to think about this a little bit. So for this test, I combined my Linux VM that is transcoding. So I've got a 4K high bitrate version of Big Buck Bunny, and I'm transcoding it to 4K at a much lower bitrate and doing both the decode and the encode on the hardware video encoder. Now this is capable of running at about twice real time, so it's running at about 115 frames per second on a 60 FPS video. Now, if I go and I run 3D Mark Night Raid, it's starting and running fine. As soon as I start the transcode on the Linux VM, it immediately monopolizes the entire GPU, and Night Raid just kind of stalls. Now, Night Raid is still running, the sound still comes out, but it's not really generating any new frames because the GPU is completely utilized. So that's one of the big disadvantages to this system. There's no sort of fairness approach for this GPU sharing. And it's possible that someone on another VM can totally monopolize the iGPU if you're passing it to more than one VM. So, to stop monopolizing this, I told FFmpeg to run at no faster than real speed. So it will delay processing to run at 60 frames per second transcode, which should use a little more than half of the GPU's resources. Now this is the video encoder, although the video encoder does use a lot of general compute on the Intel Xe platform, so still using a lot of that general compute resource. With that though, I was able to get a Night Raid score of 4,920, which is a little bit less than half. So pretty evenly splitting this GPU across those two resources, even though the video encoder tries to monopolize the whole thing. If I force it to not monopolize, it's sharing pretty nicely. And so what about 2 Windows sessions? So now I got 2 Windows VMs. They're both running Night Raid side by side in remote desktop. They're both running at 1080p, by the way. And they're both using virtual function slices of this iGPU. And they were each able to get an average of 6,018 points in Night Raid. So that's pretty much exactly half. So we're splitting the GPU resources pretty much straight in half. The CPU score was also down a bit. Again, both of these VMs had 8 cores. It's a 20-thread processor, but it only has so many P-cores, so I'm probably running out of P-cores at this point, but whatever, that's the benchmark. So this is totally working fine. And I think it's a completely acceptable performance for remote desktop users to have a little bit of acceleration from these virtual functions. So, some thoughts. When I started this, I thought it would be much harder than SR-IOV was for networking. Network cards have supported SR-IOV for a very long time. It's essentially a required feature, like an enterprise 25 gig or faster NIC. Pretty much every NIC has to support it nowadays at those speeds. All the vendors do, all the drivers are open source in Linux, and it's a great experience. Now for graphics, it's much harder. Until recently, there were essentially only 2 companies that did this kind of thing. NVIDIA, again, is on the proprietary bullshit train. They're not going to support standards because they want you to pay out the nose for licensing, like per VM licensing. Huge pain in the ass. AMD is kind of weird, so they've made like one-off cards for specific customers. It's like Google Stadia, for example, ran on AMD. I'm sure they were using SR-IOV in their setup. But those cards just never make it to the public. So it's clearly market segmentation from AMD not to support SR-IOV, but also it seems like they just aren't very good at SR-IOV, and that only supporting these drivers on 1 or 2 cards is like the best they can do. And then there's Intel. So Intel supported what they called GVT-D, I think was the name, for a while on Intel integrated graphics. SR-IOV is the replacement for that, and this is essentially PCI standards compliant instead of sort of proprietary Intel stuff. I mean, it was open source before, it was part of the Intel open source i915 driver, but it wasn't SR-IOV. So with SR-IOV, it's PCI standard. It's much easier to use for the guests, things like that. We're just using standard Intel drivers and the guests, no licensing, no NVIDIA license server, none of that bullshit. So I do question why Intel is putting so much effort into supporting SR-IOV so well. So this is with the i915 driver, which supports currently all Intel graphics except Battlemage, I believe, the Intel discrete series, including a lot of XE platform cards. They also have a different kernel driver called XE, which supports Intel, is it 12th gen and newer iGPUs, as well as Alchemist and Battlemage. And that one they're working on really heavily, and they're enabling it back on older and older cards with each release. So currently it's only enabled by default on Battlemage, but you can enable it all the way down to this GPU if you want. But Intel has put so much effort into the i915 driver that SR-IOV just works, and that really surprises me. And there's a similar amount of effort going into the XE driver, even though the XE driver is a little bit behind where i915 is right now. So there are patches that are merging into the XE driver to support SR-IOV. Currently they're not ready like the i915 one is. But I'm really hoping that they eventually bring this to what would be like the C series Intel Arc cards. Maybe it could come to Battlemage. I'm pretty sure it's not going to come to Alchemist. But whatever's next, the C series, I guess, hopefully it works for that too. Because clearly Intel is putting a lot of effort into supporting this in their open source drivers. And if they just disable it on a hardware level with a product segmentation or something, I'm sure the open source people figure out how to patch it because their entire driver stack is open source and very heavily integrated into the Linux kernel. So the one thing I do think the driver is missing though is limiting different guest functions. And there are some Linux kernel debug sysfs controls you can use. They're not really done yet is what it kind of seems like. XE has similar ones. They have a little bit more actually than i915 does. I did play with them a bit and I wasn't able to get any sort of limiting per VF. But it seems like it should be possible, it's just not implemented yet. So for me going forward, I'm keeping SR-IOV enabled on this system with this iGPU. Proxmox makes it really easy to add a resource mapping. I can add all 7 virtual functions as the same resource. That means I can have up to 7 VMs running at a time using the iGPU. Not that I'd want that, but for testing that's a lot of fun. I'm really hoping that Intel's continuing to develop this on both their i915 and their XE driver, and I'm hoping over the next few months to the next year, this eventually could come to their discrete GPUs. That would definitely be a driver for me to buy several Intel discrete graphics cards to add to these systems, because proper SR-IOV support is like a game changer for virtualization, that kind of stuff. At least if you need graphics rendering in your VMs for VDI and things like that. But as of now, we do not have that support in any discrete GPUs from Intel, just the internal graphics. So that's where we're at. If you guys want to follow along, I have instructions down below. They're going to be to the DKMS module and also to Proxmox on how to manage the host bootloader. basic stuff like that. Feel free to ask questions if you want to talk to me directly. I have a Discord server link down below for that. We can talk more about SR-IOV, virtualization, Proxmox, networking, stuff like that. I also have a Ko-fi. If you want to give me a tip, I would greatly appreciate it. I'll link down below for the Ko-fi as well. And as always, I'll see you guys on the next adventure.